Hello, and welcome to another video by Inspire Cows, the channel dedicated to dairy health. In this video, we're going to watch Professor Hans-Joachim Schuberth from Hanover University introduce you to immunology of the calf and the importance of immunology to the calf. Hans-Joachim Schuberth is one of the top veterinary immunologists in the world, and he's a great person to listen to. We're privileged to have him here on the channel, and I'd like to take this opportunity to thank him very much for providing this video.
Ladies and gentlemen, dear colleagues, my name is Hans-Joachim Schuberth. I'm from the University of Veterinary Medicine in Hanover, in Germany, and I'd like to talk with you today about the calf's immune system and the points we may consider if we advise farmers how to raise healthy calves, which will become a healthy and a high-yielding milking cow later on. Well, this is a point which always has to be in our mind, that the female calf is indeed the milking cow of tomorrow. And with a calf, we have certain aims. First, we want to raise healthy animals. They shouldn't become ill. And the second is, quite abstract at the moment, right after birth, is to program these calves to become a healthy, high-yielding cow. So we have two times the term health or healthy. And if we want to know on what health depends, then we end up rather soon with the immune system. And we want a proper immune system which ensures that the animal remains healthy. The term proper is quite important, and I will put some emphasis on this term later during my talk. We also have questions. Are there windows or time frames during the development and life of a calf when health is really programmed? When should I especially take care of this? And what are the key factors for the development, the maturation, and the maintenance of a proper working immune system? Well, let's look at this term proper working immune system. It's basically not a question of strength. In fact, we don't want to have a strong immune system. This could do much harm to the animal. We have numerous examples showing that disease mostly depends on an overshooting, acting a too strong immune system. And it's also not a question of mere antibody amounts. Having more antibodies doesn't necessarily mean that a calf is more protected or healthier. The same applies to immune cells. It's not a question of immune cell numbers in the periphery. In contrast, a proper working immune system always chooses the right decision in case of danger. Well, imagine a calf seeing a pathogenic bacteria in the gut, or seeing pathogenic viruses in the lung, or fungi on the skin, or toxins whatsoever. The different kind of dangers which are mentioned here imply that also the mechanisms necessary for the removal of these pathogens and dangers are quite different. And the choice which mechanisms should be developed or will be developed, the choice is taken at the very beginning, and this is a sign of a proper immune system if these choices are taken correctly. In sum, if an animal has a proper working immune system, it will respond in a correct and proper way to any kind of pathogens, wherever they enter the body. If a virus comes via the gastrointestinal tract or via the lung, for instance, the system will take the right direction. And this will result in effective defense mechanisms, whether this is complement activation, whether this is interferon production, whether this is at the end the generation of cytotoxic T cells or proper antibody isotypes, for instance IgA or IgG1, IgG2. This decision is made at the very start. A proper working immune system also takes care to respond silently. Silently means without much effort. The animal will respond without much clinical signs. Maybe a short period of diarrhea, maybe a short period of coughing, and so on. But in some, you won't see that the system with a proper working immune system will act very prominently. And the signs, these small signs, they will disappear rather quickly. So the immune system takes care to act rather fast. It will act quickly. This saves energy and in some will result in a healthy animal. The good thing of a proper calf immune system is that it can be programmed. We know that it can be programmed during pregnancy, so already in the cow, and it can be programmed after parturition. Here especially feeding issues are important, namely colostrum and other feeding regimes after colostrum is taken up. However, we have a problem. Colostrum management still has its serious flaws. It appears that still in 2018, roughly half of the calves do not receive enough colostrum. This was again addressed in a very recent publication, Journal of Dairy Science, you can see here, November 2018. They took serum, they took plasma samples to assess the failure of transfer of passive immunity in dairy calves. So they assessed the uptake of antibodies from the colostrum, and based on a cutoff value of 10 grams immunoglobulin G in serum or plasma, they measured or calculated that nearly half of the cows didn't receive enough colostrum. So still a serious problem. Although everyone knows that colostrum uptake after parturition is very important. So the problem is that calves do not receive enough colostrum. Let's go through some thoughts. Sorry for my humble English. So if we are dealing with failure of transfer of passive immunity, then it means that too few maternal antibodies are transferred. You may next ask whether it is the antibody concentration in colostrum determining this failure, but it's probably not the case. There's a publication of 2018 from McGee and Early. They put together colostrum IgG concentrations in the first milk of dairy cows, and you can see, depending on the year of the study and the animals analyzed, the mean IgG concentration is about 60 milligram per milliliter, and this means that probably the antibody concentration is not the real issue. So we are ending up with the answer that it's probably the transferred volume of the mere volume of colostrum which is transferred, which is too few for the calf. And if too few volume is transferred, then of course we have too few antibodies, but we may also ask, what else does the calf then miss? in addition to antibodies. And this is a serious point. We will discuss that also later in this talk. The message already at this stage is that antibodies are really only part of the story. The quality of colostrum based on mere antibody concentrations is again only part of the story. In fact, we have to readdress the question, what is a good colostrum? Okay, but step by step. If we again ask what determines a proper working immune system, we see that we have one field dealing with the mother, the cow, before parturition and especially after parturition. Then we have the point nutrition of the calf. This can be divided in the colostrum phase and the phase beyond colostrum uptake. And we have environmental factors, the kind of housing, the temperature, the stress the animal receives, and social contact, and so on. So environment, nutrition, and the mother. Let's start with the mother. What determines the way the calf's immune system deals with danger? Let's look at the pregnant cow. Summarizing the points, we would end up with two major statements. First, that the immune system development starts very early in pregnancy, and that immune organs and immune cells gradually develop. Not very impressive. During this first phase, spanning, let's say, up to 5 months, we have windows which are very important for the immune system development of the calf. This is why these windows are called windows of vulnerability. It starts the first 2 months of pregnancy with the development of myeloid cells, and it goes on with the development of lymphoid cells. The reasons for disturbances which may occur are quite unclear, but the major facts are, or the major reasons for disturbed development seem to be malnutrition on the one side and stress of the cows on the other side, in addition to the influence of environmental contaminants or toxins. Well, this was the early phase of pregnancy, maybe not so important. Remember, I don't have a special graph for this, but if a cow remains the embryo in their uterus 30 days after insemination, then the chance for embryonic loss or abortion is only 10%. This is the reason why many researchers don't look very closely at the late pregnancy. If we look, however, at the very late pregnancy, let's say the last 2 months, then we see that this period, in addition to the first days and weeks after parturition, are quite decisive for the development of a healthy animal with a proper immune system. These 2 windows, late pregnancy and the first days after parturition, they are especially important for the immune programming of the newborn, and which will decide whether an animal will suffer from more infectious diseases or more severe infectious diseases, or whether this animal, the green line, will stay more healthy, will grow better, and so on and so on. So these different developments, they have their origin around parturition, let's say it this way. Again, let's first look at the mother. The late gestation is really an important window of vulnerability. This has been addressed in numerous studies, in rodents, in humans, and also in farm animals. This paper, already published in 2008, is a very prominent one, featuring the impact of prenatal stress on the imprinting of the still unborn and its immunity later on. There are very nice studies showing that this was done with piglets, that piglets, if the mother experiences stress at this stage during late pregnancy, won't take up enough immune factors like antibodies, won't develop so well, and will be more infected during later life. There's another story I very often like to talk about. It addresses stress in rodents. There was a nice study where pregnant rats were treated, or one group was treated with dexamethasone in late pregnancy. The other group was left untreated. Then the puppies were followed for 6 months, and even after 6 months you could see differences regarding the ability of macrophages to ingest bacteria and to kill them. I haven't mentioned this paper here, but it was absolutely impressive for me to see that a stressor, glucocorticoid, in late pregnancy in the mother has long-lasting effects on the immune system, on the way it works for the newborn. So cow stress in the late pregnancy is really a deleterious factor for the immune capacity of the newborns, and very much likely also for the calf's immune capacity. When we talk about stress, we can divide this into certain kinds of stressors. For the cow, it recently has been demonstrated, 2018, Journal of Dairy Science, that especially feeding or metabolic stress is indeed associated with changes in immune parameters, immune responses, and metabolic responses of dairy cows. I mean, what we know for a long time is the term metabolic programming of cows. And if we have a metabolic programming of calves, you can easily imagine that you also have an immune programming of calves. And this is somehow guided by the metabolism, by the feeding of the cow. So transition cow nutrition is absolutely important, not only for the cow and their milking behavior after parturition, and the likelihood of having a mastitis or metritis. No, it's also important for the cow. So if the cow, for the calf, if the cow has oxidative stress, has a high degree of lipid mobilization, inflammatory parameters in plasma, if she's fed with low feed of low energy density, then you can expect that it's also deleterious for the calf's immune capacity. In addition, this is now a lesson from humans, but it can be extrapolated to any other species, is that a malnutrition of the mother has an impact on the immune system of the offspring. This was a very interesting publication where they summarized all findings addressing the impact of feeding of the mother on the vaccination response of the newborn kids. And of course, they saw effects of vitamin or trace elements on vaccination success of babies. But the key factor, for instance, here was that protein malnutrition of the mother was a dominant factor for a poor vaccine response against everything. So it means that if the mother hasn't been fed correctly or sufficiently, you can vaccinate the offspring with what you like, a live vaccine, a dead vaccine, against bacteria, against viruses. They will respond in a non-proper way. And if we put these findings on our cows and calves, it means that if cows are not fed correctly, you can expect that calves not only will respond in a wrong way towards pathogenic microorganisms, they also will respond differently or insufficiently to the vaccinations we put into them. So very interesting point. Okay, so mother is important. We just addressed some issues of late pregnancy. Now we look at the first days and weeks of a newborn calf. And it starts with colostrum uptake. Before it takes up, some thoughts about the immune system as it is when the calf comes out of the calf. In principle, the immune system of an unborn calf is already competent. Competent means that it can deal with a foreign antigen in a coordinated manner. It does not mean that the immune system can do anything at the same speed as an adult. No, but it can act in a coordinated way. It also means that the response to pathogens is already possible. This is important for vaccinations. It's not the topic during this talk, but I have to already to mention here that you can vaccinate calves already before colostrum uptake. Okay, another story. But although it's competent, although it can act in a coordinated way, the immune system of the calf still has deficits. We see it at many levels. For instance, concentrations of soluble immune components is low, whether we look at colostrum components, whether we look at complement components, of course, whether we look at antibodies, cytokines, and so on. Concentration is lower. Everything is in principle there, but lower concentration. Then the capacity of immune cells, the ability to phagocytose, as you see here on the right lower side, the capacity to kill uptaken bacteria is lower. Then, due to the fact that during pregnancy a lot of steroids are released from the mother, they also appear in the colostrum, and if they appear in the colostrum, they are taken up and affect the function of immune cells of the calf. In the center of the not yet fully developed immune system of a calf, I put it in red, is the gut immune system. At the end, and this applies for everything during the whole life of an animal, the gut immune system is the biggest system in the body, and what's happening here has impact on every immune reaction elsewhere in the body, and this gut immune system severely lacks development in a newborn calf. In addition to the spectrum of pathogen-specific T and B cells, Phagocytic capacity I already mentioned. The killing of virus-infected cells is lower. And the antibody production, the own antibody production, is still only beginning. So the calf has deficits. And if it has deficits, it means that the newborn calf is vulnerable. Quite a simple statement. If we look even closer, then we see one big point which is not yet assured, and which is then the fundamental role of colostrum to supply this. It means that the immune responses a calf has to make are not yet balanced. To explain this, I put here a way. On the left side, you see immune cell or immune cells named Th1. These are specialized T cells, helper T cells, characterized, for instance, by a high release of interferon gamma. They are normally called inflammatory. If they are acting, then you see quite a high degree of inflammation, whether in the gut or the lung, doesn't matter. On the other side of the way, you have other types of immune cells, so-called Th2 cells. As an example, they release cytokines which act mainly anti-inflammatory. If an immune response is balanced, then you always have quite a good balance between anti-inflammatory and inflammatory parameters, ensuring that an immune mechanism is not only initiated, but it's also downregulated. It's not overshooting. It's mild. It's transient. It's well, at best I can say a self-regulated, balanced immune response. And this is not yet assured. So, in this situation, where the immune system has deficits, where balanced immune responses are not yet assured, calves must take up colostrum. And they take it up for three major reasons. First is that, well, it's only placed on the first place, but this is what we all know. They take up maternal antibodies, and we think that this is due to the fact that pathogen-specific antibodies in colostrum protect the calves of infectious diseases. It's not wrong, it's only one aspect. The major aspect is here made in yellow. The major aspect is that colostrum is the first energy supply for the developing animal. And especially for the immune system, energy is absolutely necessary because it's next to the brain, the most energy consuming system in the body. And since antibodies are only, in quotation marks, only proteins, antibodies are also there to feed the immune system, to feed the calf directly after birth. And the next, or the third point, a very important point, is that colostrum is there for the maturation, the education of the immune system, and for the assurance of a balanced response in the system. For me, and this is at the moment just an opinion, it's only my opinion, so no citations. For me, the antibodies, the maternal antibodies transferred via colostrum, they are maybe just a nice and useful umbrella under which the colostrum is able to support the maturation and the modulation of the immune system. During this period, where the gut immune system and other parts of the immune system has to develop or to mature, there should be no infectious disease which could disturb these processes. Therefore, we need maternal antibodies. If we accept this and say that the maturation and education of the immune system is a far more important step or point, then we have to ask which are the major immune programming colostrum components. And here we end up with three major things. These are immune cells. These are soluble factors like cytokines and growth factors. And we have a third group. I named them together, although they are different. First, the Colostrum Oligosaccharides, a very emerging group of substances in colostrum with far-reaching and high potential, and they act together with the colostral microbiota, the sum of all microorganisms normally present in a colostrum. So all these cells, cytokines, growth factors, oligosaccharides, microbiota, they now work somehow together to ensure a rapid maturation of the immune system and its balanced responses. Let's have a look at immune cells. After all, it's not mentioned here, but I go back one slide. After all, we will have to ask whether things we do with colostrum, we freeze it, we thaw it, sometimes we heat it, or it's heated, we may ask whether these things affect the function and action of these programming components. So again, let's look at immune cells. There are two publications, consecutive publications, from the group of Kanevsky-Mularkey, published 3 years ago. They clearly showed that viable cells transferred via colostrum have an enormous impact on the immune system of the calf. First of all, cells of colostrum or colostral cells are really taken up via the gut in the calf. So they are taken up, they are circulating, they are populating the developing secondary immune organs, and they stay there. And if you compare a colostrum which was heated, in brackets killing all the viable cells, versus colostrum which was normally delivered, then you can measure differences in the cellular composition in blood of the calves. And different cellular compositions means that the uptake of maternal antibodies has led to a sort of immunomodulation in the calf. This was a rather impressive publication showing that these cells were able to modulate the immune system. And maybe a more practical thing, this is the second paper of the Kanevsky-Mularkey group, they showed that if calves take up maternal immune cells, then they respond differently to vaccinations. And if they respond differently to vaccinations, just to mention that, it means that they also respond differently to normally invading pathogens. It also means, with an extrapolation of these findings, that the decisions of the immune system after encountering danger or a vaccine is different in animals which have taken full colostrum with viable cells and others which have taken up colostrum without viable cells. At the end, and I can really underline this sentence, this group came to the conclusion that the transfer of colostrum maternal cells has a long-term effect on the development of the neonatal immune system. Again, and this is really a point to consider, if we agree or if we say, yeah, that's maybe the case. So if colostrum cells are important for the calf's immune system, then we have a problem, because freezing and thawing colostrum or even pasteurization of colostrum definitely needs to cell killing. And we can expect the development of immune system which is maybe not properly. Good. Next factors, we have cytokines, we have growth factors in colostrum, quite a lot. And the concentration of these factors is especially high in freshly taken colostrum. You see here day 1 values, colostrum taken immediately after parturition. They have high concentration of this cytokines, interleukin-1 beta, it's a pro-inflammatory cytokine. They have relative high concentration of TNF-alpha, also pro-inflammatory cytokine. This one would enable macrophages to phagocytose more heavily. Interferon gamma is probably in colostrum in a high concentration to favor antiviral responses, again to favor the phagocytic capacity of macrophages and other cells. Interleukin-6, I put here only 4 of numerous cytokines which are transferred, especially in colostrum, which can act on one side on the local cells in the gut to promote their maturation or to alter their behavior after pathogen contact. In addition, as antibodies, these cytokines are taken up, they are circulating, they are reaching secondary immune organs, they promote the development of these organs, they promote cell development. So since the immune system is all about cells and cytokines, you can imagine that they are very important. You see also that the concentration is dropping rather fast. So they measured here, the next day they measured was day 3, but the curve is rather steep. So if you take colostrum too late, or if you give too late colostrum to the calves, then the concentration maybe is too low. In addition, the relation between these cytokines will change, and this will also have a different effect on immune cell development in the calf. Same thing as with cells. So if they are important for the calf's immune system, then we again have to reconsider whether freezing, thawing, pasteurization may have an effect on this. And here the literature is a bit, let's say, unsure. Normally in the literature they look at only special cytokines, and here you can find papers saying yes, freezing, thawing, pasteurization inactivates them. Others are saying they don't inactivate them. Again, my opinion is that they are very, very, in part, for instance, the chemokines or other growth factors, they are very sensible to temperature. So it really might be the case that every alteration of colostrum affects cytokine concentrations and relations between growth factors. The last point are the oligosaccharides and the microbiota. The colostral oligosaccharides, they are becoming more and more and more important. Basically, these different small sugars are extensions of the lactose biosynthesis. In women, we have high concentrations in colostrum, so human colostrum oligosaccharides, they are present at a concentration of 20 grams per liter. In the sow, we have 12 grams per liter. And in the cow, interestingly, we have 1 decade less. It's about 1 gram per liter, but at least 1 gram per liter. The next important thing is that we have really a lot of these colostrum oligosaccharides in colostrum, between 60 and 100 different species. There are still open questions whether distinct colostrum oligosaccharides are important, whether the concentration is important, whether the combinations or ratios between oligosaccharides is important. This is an ongoing field of intense research, and also in the cow papers addressing this issue, they are coming up. There was a very, very nice review from Bode in glycobiology summarizing the effects of human milk oligosaccharides, saying that every baby needs a sugar mama. And for me, I mean, if you dive into that subject of colostrum oligosaccharide, you realize how important this also may be or is for the calf. So just to look at the different functions or tasks of colostrum oligosaccharides, they are really multifaceted tools. First of all, they act as prebiotics for commensals. So if they are there, the good ones are favored, outcompeting the bad ones. You see, if they are lacking, HMO means human milk oligosaccharides. If they are lacking, you may have an expansion of pathogenic bacteria. Then they can act like antibodies. They can bind with one arm to the pathogen and thereby inhibiting its binding to epithelial cells. So they inhibit pathogen adhesion. Wonderful job. They not only bind to pathogens, as you can see here, but also to epithelial cells. And this binding to epithelial cells leads to a reprogramming of these cells, a very important issue. We already talked about programming, and programming of the inner and outer surfaces of an animal is a tremendously important fact. You see here that the interaction of oligosaccharides leads to an altered expression on the surface. It leads to an altered proliferation, differentiation, and apoptosis of the cells, to a different cell cycle behavior of the cells, and to a differential gene expression. In addition to these effects on epithelial cells, colostrum oligosaccharides also have a direct effect on immune cells. And here you see an interesting thing. If they are not there, if they are not there, then T cells favor the development into one direction. If they are there, the T cell responses are somehow balanced. Here we have a nice explanation why colostrum uptake leads to a balanced immune response. Cells with different functions, inflammatory, anti-inflammatory, they are generated in a more balanced way. The oligosaccharides also lead to a different adhesion, rolling, and migration behavior of immune cells into the body, and so on. So in fact, these family of oligosaccharides has numerous effects. In some, they educate mainly in two ways. You see here in the center a triangle between Colostrum Oligosaccharides, Microbiota, and on the other side, in blue, immune cells and epithelial cells of the newborn. First of all, Colostrum oligosaccharides favor the growth and diversification of intestinal microbiota, a very important point. And the second, Colostrum oligosaccharides have a direct action on resident cells, namely immune cells, epithelial cells. And since microbiota also have an influence on immune cells, a direct influence, and a direct influence on epithelial cell, you see that these three components act together or are dependent on each other. For me, this is a really decisive point. For instance, for microbiota, it has been shown that their adhesion to epithelial cells leads to a promoted villus growth in the gut, that this interaction leads to a promoted tolerance against food ingredients and harmless bacteria, that this interaction leads to inflammatory conditions which are dampened, not so fulminant, not so clinically apparent. So if we have, for instance, commensals in a proper composition and so on, then we have less diseases, and we have these commensal or these proper mixture of healthy intestinal microbiotes if their growth is favored, and it's favored because we have in colostrum so many oligosaccharides. Since we don't place so much effort on the determination of colostrum oligosaccharides, but only antibodies, we simply don't know whether calves receive enough of them. So the only workaround, again repeated at this stage, is to provide as much colostrum as possible to the calves to ensure that it receives enough of these colostrum oligosaccharides, in addition to cytokines, chemokines, growth factors, and immune cells. Here you can see again how these oligosaccharides taken separately and these microbiota in the gut taken separately have one aim for the whole system, namely to ensure balanced inflammatory responses. This was very nicely summarized in this paper of He and others, 2014, where they analyzed what epithelial cells produce after they were flooded with colostrum oligosaccharides. And they showed that everything which is upregulated during vigorous, strong inflammatory responses were downregulated. So this kind of response of epithelial cells after contact with oligosaccharides inhibits overshooting inflammations, and many things related to tissue repair, wound healing, these genes were upregulated. So in sum, it's an assurance of balanced responses. If we look at the microbiota at the right side, we also see the same principles. They can act directly via cell-cell contact with epithelial cells, or they can act via releasing metabolites like short-chain fatty acids. And the metabolites of these intestinal microbiota, they ensure, we can go down to these arrows, they ensure that we have a balance between inflammatory and anti-inflammatory responses. So two systems are working for the same aim, namely to ensure balanced effects. For microbial metabolites, it is long known that they really shape immune responses. You have on the one side, this is only part of the story, published 2018 in Branches of Nutrition. You have a long list of metabolites, and for these metabolites, either in animal trials or in vitro assays, the effects were recorded, and you see, for instance, for short-chain fatty acids produced by intestinal microbiota, they improve the intestinal barrier, they act in a more anti-inflammatory way, and for other constituents produced by the microbes, it has been shown that they are involved in the immunomodulation. So calf health, this would be a short summary, depends on gut microbiota, and gut microbiota diversity depends on, at first, colostrum uptake. And this would be the in-between summary. Many things I've already taken. Colostrum favors the generation of a so-called healthy microbiota. It directly favors epithelial cell and villus growth in the gut, and it favors the attraction and regulation of immune cells in the gut. And if you just look at this picture, composed of innate immune cells like macrophages, dendritic cells, some T cells here, microbiota, epithelial cells, you realize that the task of colostrum is clearly exceeding the mere protecting task of transferred maternal antibodies. Okay, again, points to consider. If we accept this, that oligosaccharides and colostral microbiota are important for the calf's immune system, again, what does freezing thawing do with colostrum? What does pasteurization do with colostrum? Pasteurization clearly kills microorganisms. And so the normal components, the normal microbiota of colostrum is also deleted. Freezing thawing, you may think, well, oligosaccharides, how they can be they affected by freezing thawing or pasteurization. But there are already studies out in the literature, year 2018, from the group of Michael Steele. They show, for instance, that heat treatment of colostrum alters the concentration of oligosaccharides. They change their association with fat globules or something else, and so heat treatment immediately has an effect on the ratio of different oligosaccharides and their concentration. And if we have this effect, we can also expect that heat-treated colostrum has a different kind of immunomodulatory potential than non-heat-treated colostrum. In sum, we have to re-evaluate whether these things we do with colostrum, or we might do with colostrum, alters the three major programming ingredients: cells, cytokines, and colostral oligosaccharides microbiota, whether important. Well, having all this in mind, then the major things to consider are that we should focus more on volume uptake. Volume of colostrum which is taken up immediately after calving. Immediately, because most of the constituents are of highest concentrations in the very early colostrum. It should provide it very early, as soon as possible and as much as possible. We should not restrict. There are numerous papers saying, well, 10% of body weight and so on and so on, and but I think do not restrict. Feed as much as you can. Minimum should be 4 liters. This should even be continued. There's a discussion whether calves should receive only colostrum once, or whether we could extend this period where they receive more of these ingredients present in the first milk. So colostrum should be provided as long as possible. If it comes to the question which is most likely the best colostrum, there's a kind of ranking. It should be fresh, because we saw that freezing, pasteurization, thawing might alter the constituents. It should be from the own cow. The own cow is mentioned here because earlier it has been demonstrated that cells from the own cow, or lymphoid cells from the own cow, are able to cross the epithelial barrier in the gut of calves and not the cells of other cows. Well, this is a bit, at least it's in doubt, as long as we don't know it. The colostrum from the own cow is still the best choice. Next thing would be a fresh colostrum from another cow. A cooled colostrum is better than a pasteurized colostrum. And lastly, the frozen thawed colostrum would be a choice if other colostrum sources are not available. But again, see the focus on the volume to ensure the delivery of as much oligosaccharides, as much cytokines as possible into the gut and then into the circulation of the calf. There are trials outside trying to measure the effects of a changed colostrum management. I mean, if you listen to these findings, thoughts, balanced immune response, and so on, you might think, yeah, there's something, some truth in it. Okay, and then you go out to the farmer and say, well, please consider to change a bit your colostrum management. And this was indeed benchmarked. What happens if, for instance, farmers feed an increased colostrum volume at first feeding? Remember, I placed the focus on the volume. Or if they reduced the time to first colostrum, if they placed more emphasis on the very early feeding of colostrum, then they analyzed what happens if farms were advised to change one or more of these factors. 15 of the 18 farms involved in these studies made changes, so they agreed to the value of these points. And in all of these 15 farms who made changes, whether they made 1 or 3, they saw a declined rate of failure of passive transfer, and more important for the farmer, the average daily gains at the beginning, they were truly enhanced, meaning that the immune system took not so much energy away from the food, it could go into growth. If the immune system wouldn't work properly, it would take too much energy and you would see reduced daily gain. Okay, so it's very important to convince the farmer that if he draws on certain screws, which he can draw, here, increased volume, reduced time to first colostrum, then it will have a direct effect on the productivity of their calves. And what you cannot see at the moment, and which is often hard to believe for many people, these calves, supported by more colostrum or earlier feeding, they will become cows which are healthier and which are more productive than others. It's my true belief. Last point. Let's look at nutrition beyond colostrum, and let's look at environmental conditions. What is known about that with regard to a proper working immune system? Well, this addresses now mainly a feeding issue, and this is really not so easy. You can talk about high or low protein diet, processed foods, hydrolyzed proteins, amino acids, mineral supplementation, short-chain fatty acids, and so on and so on. There are numerous reports out there taking these isolated issues and analyzing this on the level of the animal or in vitro on the level of certain immune cells. You can see gene expression in tissue, altered gene expression in tissues. You can measure an altered immune cell composition or immune cell function, and if you change one of these parameters. In part, there are also conflicting results. So it is not my task. I could not do that, to mention everything and to put this into one or three summarizing sentences. The overall conclusion is, or the overall view is, that the food an animal gets or is taken up always feeds two components. First, the animal itself, it takes up constituents like protein, fat, sugars, and the other system are indeed the microbiota in the gut. We addressed this point already when we talked about oligosaccharides. And the effectiveness, this is guided by the environment. This was quite interesting to see. It was published recently, 2018, in a well-reputed journal, Frontier of Immunology. And they looked at the development of gut immune cells here. And they simply asked whether the environment, they compared intensive and extensive farm environments, in addition to antibiotic use, whether these environments have an impact on this. And they come to the conclusion, and their findings were that the kind of management and housing has a direct impact on the gut microbiome. And the gut microbiome itself has a tremendous impact on the feeding efficiency of the animals. And feeding efficiency and the gut microbiome itself, they have a direct influence on the immune system. They saw it when looking at the immune cells in the intestinal mucosa, and outside in the farms with different environments and management conditions, you will see it in an altered incidence of gastrointestinal infections or lung infections, for instance. So in fact, it's not only feeding, it's also the environment which guides the impact of feeding on the immune system. Let's come to an end. We talked a lot about the calf's immune system development and realized that it starts in the cow. Here, especially in the last or in the late pregnancy, we have a kind of immune programming of the animal, which is very important. Therefore, high impact should be given on transition cow nutrition. The biggest issue, if we are looking at the newborn calf, is of course still the colostrum management and supply. And I talked a lot about immune programming components in colostrum, which are of enormous importance for the development of a proper immune system. Later, immune system maturation, immune system education, insurance of balance in the immune system is mainly guided by feeding. Here we need enough energy, we need highly digestible protein sources. We also have always to consider that we feed two systems, the commensals in the gut and the calf, and that the feeding efficiency and lastly the achieved immune modulation are also dependent on environmental conditions and the management procedures on the farms. I thank you very much for listening. For every one of you who wants to read further, I included a list of the references I cited in this talk.
Thank you for watching, and if you like the video, then click on the bell, click on subscribe, and click on like, and hope to see you again in the next one.